Welcome to Module 4 of the Works Clearinghouse Group Design Standards training. You can access all the resources mentioned in this module through the WWC's website, whatworks.ed.gov. This module focuses on the WWC standards related to outcome measures used and reported in studies, as well as the WWC standards related to confounding factors. In this module, we will define an outcome measure. We will define the WWC outcome measure standards and then demonstrate how to apply them. We will also define a confounding factor, and we'll describe how outcome measures and confounding factors can affect a study's WWC research rating. The first step in assessing findings in a randomized controlled trial or quasi-experimental design according to WWC group design standards is to review the outcome measures used in the study and to examine the study for the presence of confounding factors. These are really two steps, but they are presented together because they are usually completed prior to the in-depth review of the study's research designs, because it is at this step when the WWC determines whether the study review advances. Remember that we have already discussed the different types of RCT and QED designs that are eligible for review under the group design standards. This was discussed in the previous module for the purposes of training, but again, reviewing outcome measures and checking for confounding factors is usually completed prior to the in-depth review of the study's research design. If a study does not have a single finding that was measured using an outcome measure consistent with WWC standards, or if the study contains a confounding factor that affects all findings, the study will receive a research rating of does not meet WWC standards, and the review will stop at this point. So let's begin by discussing the WWC's outcome measure standards. First, we need to define what the WWC means by an outcome. An outcome is the knowledge, skills, attitudes, behaviors, or other measurable characteristics that researchers measure to learn about the impact of an intervention. Eligible group design studies estimate the effectiveness of an intervention by comparing measured outcomes from a group that receives the intervention to outcomes for a group that did not receive the intervention. The term outcome measure refers to an instrument, device, or method that provides data on the outcome of interest. Impact evaluations use outcome measures to estimate the effect of the intervention. For example, studies commonly use achievement tests as outcome measures. Finally, the term outcome domain refers to a group of closely related outcomes that provide information on the same underlying construct. The WWC's study review protocol describes all eligible outcomes and outcome domains of interest to the WWC. This figure shows an example of these concepts of outcome domains, outcomes, and outcome measures, and highlights the differences between these three terms. One outcome domain of interest to the WWC is phonics and related alphabetics. Within this outcome domain, there are several different types of outcomes, including letter identification, phonemic awareness, phonics, phonological awareness, spelling, and print awareness for the English language. And for each of these outcomes, there are different types of specific outcome measures that can be used to provide data on phonics and related alphabetics. For instance, some researchers might use the dynamic indicators of basic early literacy skills, or DIBELS, letter naming subtest as a measure of letter identification. Or perhaps researchers might use the phonological awareness test, or PAT, to measure phonological awareness. Researchers often examine multiple outcome measures within a study. So how does the WWC determine which outcome measures to review? Once a reviewer has verified that the outcome belongs in an eligible domain described in the study review protocol, the WWC applies its outcome measure standards to determine whether the measure used to estimate the effect of the intervention are credible. Let's start with an overview of the outcome measure requirements, which we will discuss in more detail throughout the module. First, the outcome measure must have face validity. That is, it must measure what it claims to be measuring. Second, the measure must have sufficient reliability. That is, it must produce the same types of scores if it is administered over and over to different people in different settings, and so on. Third, the measure must avoid overalignment. When an outcome measure is closely aligned or tailored to the intervention, the study findings may not be an accurate indication of the effect of the intervention. Again, we will go deeper into this concept shortly. Fourth, the outcome measure must use consistent data collection procedures for the intervention and comparison groups. In other words, did the researchers collect data for the measure in the same way for the intervention and comparison groups? Any difference in the outcome measure between the intervention and comparison groups should relate to the intervention and not the measurement process or the measure itself. If a study does not include at least one eligible outcome measured in a way aligned with these 4 outcome measure standards, it will receive a rating of does not meet WWC standards, and the review will stop. So let's dig deeper into each of these standards. Let's first examine the concept of face validity. An outcome measure must capture what it claims to measure for the study to appropriately capture the intervention's effect on an outcome of interest. The WWC says that an outcome measure has face validity when it has a clear definition and captures what it claims to measure. When assessing face validity, the WWC requires alignment between the description of the measure and the content of the measure, such as the questions on a test. For example, if the measure is called a math achievement test, does it measure students' math knowledge and skills? And remember, the study review protocol provides a non-exhaustive list of established, independent measures for math and literacy-related domains. Measures on this list are known to be independent, and reviewers can assume these measures have face validity. We discuss the issue of independent measures in more detail later in this module, as well as what a reviewer should do if they encounter a measure that is not on the list and believes that the measure should be one of the listed independent measures. If an outcome measure does not have face validity, then differences in outcomes between the groups do not provide information about what they claim to measure. When conducting a study review, WWC reviewers will assess whether a measure has face validity or not. This assessment is based on the information that study authors have reported. So the WWC generally assumes a measure has face validity unless there is compelling evidence in the study that suggests otherwise. If reviewers are unsure whether a measure has face validity or has potential concerns about the face validity of a measure, they can flag this for consideration by review team leadership. Any finding based on an outcome measure without face validity will receive the does not meet WWC standards research rating. Outcome measures must also have a high degree of reliability to meet WWC requirements. The reliability of a measure captures whether it would yield consistent scores from different administrations. A highly reliable measure indicates that the observed scores have low measurement error. For example, a reliable measure will return similar results if a study gives the same assessment to the same group of students repeatedly. So let's imagine that these target images represent the outcome measure of interest. The center of the target represents the concepts that the outcome measure claims to measure. An outcome measure with reliability produces measurements that hit the target consistently and in the same general area. 2 of these images represent an outcome measure with reliability. The first target represents a measure that is not reliable because the results are scattered across the whole target. The results in the second target are clustered in a single area, so this measure is reliable. The results do not need to hit the center of the target to be considered reliable. The third target represents a measure that has both face validity and reliability because the results are clustered at the center of the target. So how does the WWC assess reliability? There are 3 ways for an outcome measure to meet the reliability standard. The first way to demonstrate reliability is to offer evidence that the individual items or questions in an outcome measure provide consistent information about a respondent's knowledge, skills, attitudes, or behaviors. This is called internal consistency. For an outcome to have high internal consistency, the items in the measure must focus narrowly on a set of key concepts. For example, a measure that includes items that assess both reading and math skills is unlikely to have high internal consistency because some students will score high on the math items but low on the reading items, or vice versa. The second way for an outcome measure to meet the reliability standard is to demonstrate sufficient test-retest reliability. Test-retest reliability measures to what extent the same individuals get similar scores in repeated assessments. The third way to demonstrate that an outcome measure has reliability is by showing that different raters scored the same individual similarly, a measure called inter-rater reliability. It is important to note that researchers often only report one of these types of reliability estimates. If the authors do not demonstrate that the outcome measure is reliable using at least one of these methods, then any finding using that outcome measure will receive the does not meet WWC standards research rating. The WWC uses the following reliability standards for assessing whether an outcome measure is reliable. For measures of internal consistency, the WWC requires an internal consistency statistic of 0.6 or higher. Low internal consistency means that the items on an exam aren't really testing the same thing, so high or low scores might not represent meaningful differences in skills or abilities. For measures of temporal stability or test-retest reliability, the WWC requires a reliability statistic of 0.4 or higher. Temporal stability can be particularly important when authors want to use the same exam at several different time points to establish that 2 different groups are equivalent, or they want to demonstrate differences in growth in an outcome across time between an intervention and comparison group. If temporal stability is low, apparent change might be a result of measurement error rather than true learning. For measures of inter-rater reliability, the WWC requires inter-rater reliability correlation statistic of 0.5 or higher. And for measures of inter-rater agreement, the WWC requires % agreement reliability statistics of 0.8 or higher, or kappa statistics of 0.6 or higher, based on 20% of the inter-rater judgments. Agreements between raters is particularly important when the outcome of interest is the result of direct observations, such as recording how often a student is off task. If different raters don't generally agree on when a student is off task, this might mean that the definition of off-task behavior is not clear, or the observers need more training. Either way, observations by different raters might actually be measuring different things, even if they both consider themselves to be observing off-task behavior. Future versions of the study review protocol may specify any reliability requirements that are different from or additions to the standards we just discussed, so reviewers should always refer to the current version of the study review protocol when conducting a study review. Sometimes a reliability statistic is not available for an outcome measure. In some cases, even if the study does not present a reliability statistic, the outcome measure can be deemed to meet the face validity and reliability requirements. Administrative records may include standardized tests that are routinely administered by states or districts, or records that schools or institutions might collect as part of their standard record keeping, such as records of attendance, graduation, degree attainment, course credits, or disciplinary incidents. The WWC automatically considers outcomes measured using administrative records to be valid and reliable, because these outcomes are straightforward to measure and they measure what they purport to measure. Standardized tests are a common type of administrative records used in education studies to estimate the impact of an intervention. A standardized test is an assessment given to all test takers using the same set of procedures. In most cases, standardized tests have established administration and scoring procedures. Generally, the measure reports scores in relation to a normed sample so that people can compare scores from different settings. Again, the WWC typically assumes that standardized tests, which are a type of administrative record, demonstrate face validity and reliability. So why is that? Well, we assume they have face validity because test developers design standardized tests to measure a specified set of concepts. So, by definition, the test scores have face validity. And why do we assume reliability? Standardized tests have established administration and scoring procedures. Test developers typically examine items to ensure that combining the items into a scale score produces a reliable resulting score. So, if a study uses a standardized test and administers and scores the test according to the procedures outlined by the test developer, the WWC assumes that the measures meet face validity and reliability requirements. Using our target image to illustrate this point, the WWC assumes that standardized tests are consistently close to the bullseye, demonstrating both face validity and reliability. Another common form of administrative records used to assess outcome measures are grade point averages or GPAs. Again, the WWC typically assumes that grade point average outcome measures have face validity and reliability, assuming consistent data collection has been used across the sample included in the study. However, it is important to know that if a study includes different school districts or different institutions of higher education in the same study, the WWC review team will need to confirm that the same scale of grade point average has been used across sites in order for that measure to be considered reliable. A final form of administrative records that the WWC may consider valid and reliable without reliability statistics are any outcome measure that can be scored with very low error by a single coder. Review team leadership may make exceptions for these types of outcome measures, deeming them to be valid and reliable even in the absence of reliability statistics. Examples of measures that might be scored with very low error could include, for example, the number of words read correctly per minute, the ability to recite the alphabet or not, or the ability to count to a predetermined number. So, how can WWC reviewers recognize whether an outcome measure is from a standardized test? There are several things to look for, any of which will indicate that the WWC considers the outcome measure to be from a standardized test. If the measure has a trademark or a reputable testing organization developed it, the WWC considers it to be standardized. The WWC also considers measures with technical manuals to be standardized. Well-known measures for the field and those with established scale scores are also typically standardized tests. Finally, the WWC considers state and district achievement tests to be standardized measures. However, according to the WWC, outcome measures developed by the researchers of the study are not standardized tests because the measures typically do not have any of the properties of standardized assessments. There are a few other things to bear in mind when deciding whether or not an outcome measure is standardized.
First, the measure used in the study must be an established scale or subscale, not just a researcher's selection of items from a standardized test. For example, the developer of the Woodcock-Johnson test has identified several subscales, including calculations, letter word identification, and passage comprehension. If the study administers specific questions from a test, authors must use the predetermined subscales in their entirety to properly analyze and score the data. It is also acceptable for an administrator to combine two established subscales from a standardized test as long as the study uses both subscales in their entirety. If there is evidence that study administrators did not follow these procedures, the WWC does not consider the measure to be standardized. Next, even if a standardized test has established administration procedures, researchers may sometimes deviate from those procedures when administering the measure. This is a concern because the developer of the measure determined the properties based upon specific established procedures. If researchers deviate from those procedures, it may affect the validity and reliability of the measure. If the study contains evidence that the researchers did not follow the established administration procedures, the WWC does not consider the measure to be standardized.
Let's discuss a few examples of issues that may raise concerns about standardized tests. For example, as discussed previously, if researchers use a standardized test but drop one or more items from the test to meet their unique needs, this would no longer be considered a standardized test that is assumed to be valid and reliable. Or, in our second example, let's say a researcher is studying low-achieving first-grade students. Because the students are low-achieving, the researcher decides to use a test designed for kindergartners. This is a concern because the original test developers have not established that the test is appropriate for measuring the outcomes of first-grade students. In the next example, let's say the developer designed a measure for one-on-one test administration, but researchers administered it in small groups for their study. This is a concern because the administration of the outcome measure deviates from the approach the developer established. And finally, in the last example, let's say a research team uses a different threshold to calculate scores for a measure. In this example, the developer requires valid responses for 95% of items to generate a score. But let's say the research team calculated scores when only 90% of items had valid response. This is a concern because it is not consistent with the developer's established scoring procedures. Returning to the WWC's overall outcome measure standards, the third standard is that outcomes must avoid overalignment with the intervention. So what do we mean by overalignment? Overalignment occurs when a study closely tailors a measure to the intervention condition, or the measure repeats some aspect of the intervention condition. If a study closely aligns or tailors outcome measures to the intervention, the study findings may not accurately indicate the effect of the intervention. Let's consider an example. Imagine a study which students in the intervention group read certain passages, but students in the comparison group do not read those passages. And let's say the outcome measure for the study is a test that includes the reading passages used in the intervention group. This outcome will not provide a fair test of the intervention because the students in the intervention group have an advantage to their prior exposure to those passages. Even if the intervention has no effect on reading ability, intervention group students might still score better than comparison group students, simply because the intervention group students are familiar with the passages on the test. So, a comparison of outcomes between the intervention and comparison groups may provide an unrealistically favorable assessment of the effect of the intervention. The decision about whether an outcome is overaligned or not is made by review team leadership. Any findings from an overaligned outcome measure will receive the does not meet WWC standards research rating. So what are some examples of outcomes that might be overaligned with the intervention? Imagine that researchers reported on an outcome measure that was based on an assessment that relied on reading materials or vocabulary words that were used only in the intervention condition, but were not used in the comparison condition. This would be an example where the outcome is overaligned with the intervention. In another example, imagine researchers used an outcome assessment in some novel format, which was used regularly in the intervention group, but not the comparison group. Again, This could mean that the outcome is overaligned with the intervention. Now, there are other common scenarios that may occur that may seem similar to overalignment, but which may not truly reflect overalignment. For example, if researchers examining the effect of a reading intervention assess student outcomes using a test of reading comprehension that used novel reading passages that were not present during the intervention, then this outcome would not be considered overaligned with the intervention. And finally, overalignment is not considered to be present if the material covered by an outcome measure must be explicitly taught. For example, reciting the alphabet requires being taught the alphabet. The WWC would not consider this measure overaligned in situations where teaching young children to recite the alphabet is a developmentally appropriate component of the intervention. Another example might include an intervention that involves a new Algebra 1 curriculum for teaching students how to factor polynomials, replacing the typical curriculum on factoring polynomials. So long as an outcome measure did not draw on specific examples from the new curriculum and does not require that the students perform steps specific to the novel approach contained in the curriculum, an outcome measure that included factoring polynomials would not be overaligned with the intervention. We have now discussed 3 of the 4 review requirements for outcome measures: validity, reliability, and overalignment. The 4th standard is that the study must collect the outcome measure in the same manner for intervention and comparison groups to ensure that post-intervention differences between groups is a result of the intervention and not a result of data collection differences. If the mode of data collection differs between groups, then the difference in the observed outcome between the intervention and comparison groups may be attributable to something related to the outcome measure itself, not just to the intervention. For this reason, any findings from outcomes that fail to meet this requirement will receive the Does Not Meet WWC Standards research rating. So what might inconsistent data collection procedures across conditions look like? Suppose a study examines the effects of a dropout prevention program and uses student attendance as the outcome measure. For the intervention group, students self-report their attendance rate on surveys. But for the comparison group, the researchers obtain student attendance data from school administrative records. Students in the intervention condition may report attendance rates much higher than the rates that would appear in administrative records. If so, differences in data collection mode could cause an observed effect on attendance, apart from any real effect of the intervention. Again, this is why if a study collects outcome measures differently by condition, the WWC will rate the finding from those outcomes as does not meet WWC standards. The WWC considers several types of issues when deciding if the data collection differed between groups. The first issue is differences in mode of data collection, as in the example where the researchers used survey data in one condition but administrative data in the other. Another issue is differences in the timing of data collection. If the study measured outcomes at different points in time for the 2 conditions, the additional time in one condition might influence the results. For instance, if outcome data are collected at the end of the fall semester for the comparison group and at the end of the spring semester for the intervention group, any learning or development that takes place during the spring semester could be part of the observed impact of the intervention. Differences in the personnel involved in test administration and differences in the procedures used to construct scores could also influence the results. Each of these examples leads us to question whether the estimated impacts are due to the intervention or simply due to differences in the measurement of the outcomes. Now, some studies may not directly discuss these aspects of outcome measurement. So, if there is nothing in a study that suggests different data collection procedures across groups, then the WWC assumes that the processes were the same across groups. Measure independence is one additional consideration the WWC will make when assessing outcomes, and this is a new consideration under version 5.0 of the handbook. The independence of an outcome measure refers to whether an outcome measure is independent of the intervention. The WWC only considers the independence of outcome measures for math and literacy-related domains, as specified in the study review protocol, and depending on the purpose of the review. The WWC considers a measure to be non-independent if either it was developed by study authors and is not in broader use, or if it was created by the intervention's developers. This means that measures created by study authors will be considered non-independent unless there's evidence of their broader use in the field. And this means that measures created by developers to accompany an intervention are always considered non-independent when used to estimate the impact of the same developer's interventions. Conversely, measures from administrative records, such as those from a local or state education agency, are considered independent because they are typically not developed for a specific intervention. So what role does measure independence play in the WWC review process? Well, for math and literacy-related outcome domains specified in the study review protocol that require an assessment of measure independence, findings based on non-independent measures cannot be designated as main findings for individual study reviews. When assessing outcome independence, study review teams should refer to the definition of non-independence specified in the handbook and consult with the list of known independent measures that is compiled by the WWC and appended to the study review protocol. Importantly, study review teams should be aware that a measure's independence designation may change over time. For instance, moving from non-independent to independent if different study authors begin to uptake the measure for wider use beyond its original development setting. The WWC will document any changes in the independence designation in this list of independent measures, which is again included in the study review protocol. It is also critical to note that the WWC's list of known independent measures should not be considered exhaustive. For instance, a study might use a measure that meets the definition of non-independence that is not currently on the list. If a review team encounters a measure that meets the definition of an independent measure, but it is not currently included on the list of independent measures, the team should submit a WWC help desk request for the WWC to review the measure and consider adding it to the list of independent measures that is appended to the study review protocol. Time for your first knowledge check in this module. Researchers recruited 8 universities in a Midwest state to participate in a study of a new online undergraduate chemistry course. Half of the universities were randomly assigned to implement the online chemistry course, which served as the intervention group. And the other half of the universities continued to implement their traditional in-person chemistry course, which served as the comparison group. The researchers measured the chemistry knowledge of all students enrolled in chemistry courses at the participating universities before and after the intervention using a standardized test, the Educational Testing Service Major Field Test in Chemistry. The researchers administered the test to the intervention group students, but course instructors administered the test to comparison group students because the college administrators did not grant the researchers access to chemistry classrooms. The researchers reported that, after controlling for pre-test scores, the comparison group students had higher post-test scores than the intervention group students. What is the highest research rating any findings on the standardized test from the study are eligible to receive? Your answer options are A. Meets WWC standards without reservations. B. Meets WWC standards with reservations. C. Does not meet WWC standards. And D. This study is not eligible for review and cannot receive a research rating. You may want to pause the video while you think about your answer. The correct answer is C. The highest possible rating of a finding on the chemistry standardized test outcome from this study would be does not meet WWC standards. This is because the outcome does not meet WWC outcome standards. Namely, the researchers in this study used different data collection procedures for the intervention and comparison groups. The personnel who administered the chemistry test were different for the intervention and comparison group students. Therefore, this outcome does not meet the WWC outcome measure standards, and any findings from the study on that outcome should be rated does not meet WWC standards. Now let's check 2. In a quasi-experimental design study, researchers assessed the effectiveness of a geometry intervention for 9th grade students on 3 outcome measures. The first outcome measure was a math achievement test administered by the school district. The second outcome measure was course credits in geometry at the school. The third outcome measure was a geometry problem set the researchers developed, which had a reported test-retest reliability statistic value of 0.33. How many, if any, of the study's outcome measures meet the WWC outcome measure standards? Your answer options are A, none, B, 1, C, 2, and 3, D. You may want to pause the video while you think about your answer. The correct answer is C. Based on the information provided, 2 of the 3 outcome measures from this study would meet the outcome measure standards. The district math achievement test is considered a standardized test that is presumed to have face validity and reliability, since there is no indication that the administration of this test deviated from established procedures, nor any indication that the outcome was overaligned with condition. The WWC also considers administrative records collected by school districts, such as course credits, to be valid and reliable without reported reliability statistics. In contrast, the third outcome measure, the chemistry problem set, would not meet WWC outcome requirements. Although the chemistry problem seems to have face validity, it also needs to demonstrate reliability, since none of the information provided indicates it is a standardized test, nor is it based on administrative records. Although the authors do report a reliability statistic for this outcome, the test-retest reliability statistic falls below the minimum acceptable value of 0.4, which means this outcome does not demonstrate adequate reliability. So, only 2 of the 3 outcomes in this study meet WWC outcome measure standards.